So thank you everybody for coming to Love Data Week. It's great to see such a wonderful turnout. This week is done in collaboration with the Becker Medical Library, the Institute for Informatics, I2, and university libraries. I am a librarian from the Danforth campus. I am the GIS librarian and social science data curator. And I just want to introduce my lovely data services team. So Jennifer Moore is the head of data services. And our newest member of the data services team is Sarah Swans, which is the humanities data curator and data services librarian. Then we have Molly Webb, who is our data and GIS developer. And then we have Bill Winston, who is our data and visualization analyst. And our core services ranges from data management, curation, literacy, analysis, visualization, and geographic information systems. And before I start this workshop, I just want to give a overview of all of the events we have this week. So previously today, we had a presentation from the Center for Administrative Data Research, which gave an overview of their resources and data demonstration. And then tomorrow we have a workshop on computing basics and using cryo-electron microscopy to study the 3D structure of macromolecules from our colleagues at the medical campus. On Wednesday, we have 2 workshops based in the Danforth campus: photogrammetry for architecture and community standards for 3D data preservation. And then Thursday, we have 3D drone imaging. And then we have our keynote. And then finally, to wrap things up, on Friday, we have an introduction to R that is focused more on introducing you to advanced data visualization. And then we have a very interesting discussion on the WashU Geospatial Working Group, which is a new initiative that started maybe later last year. And then finally, we wrap things up with an introduction to photogrammetry. So to give an overview of this workshop, I'm going to show you what is available on the Census website. So we're going to go over around 4 data products on the Census website. And then after that, we're going to take a short break. And then we're going to do some hands-on demos of what you can do with the Census API, application program interface, with the Python and R programming languages. And then we're going to wrap things up. There's not going to be a demo of this because I have a lot to pack in 2 hours, but we're going to also then talk about some products, other products that uses census data. So to go over the workshop materials that I sent you in the email a few days before today's workshop, and the link that's in the chat right now, in the workshop material should be the Love the Census demo worksheet, which gives step-by-step instructions on how to do all the things that I'm showing today. So feel free to join in, or if you don't want to do that, feel free to just watch. After that, we have the census data demo with the Jupyter notebook. I have the link to that notebook in that worksheet. It's actually a notebook that's been rendered to my GitHub repo, which means that all of the code output has been processed. So you won't have to click or do anything there. You'll just be following along. But if you are an experienced Jupyter notebook user, feel free to download it and tag along, and just know you will have to install some libraries. That's one reason why I sent it out like a few days before. So if you wanted to do that, you could. And then finally, there is a link to the Tidy Census Library RStudio project. We will go over the details of using the RStudio Cloud, just in case you haven't used it. so we can get you set up, but I'm not going to go over that right now. So right now, I'm going to give a brief overview of the census products that are available on the census website. And just know that these are not exhaustive. Like, this is only a little snippet of what they have. The census actually produces a lot, and it's really impossible to cover everything in 2 hours and what products the census has. But I picked the top 4 based on my experience using census data, and just based on the type of questions I get from people who ask me about various kind of demographic data. So we're going to go over the data.census.gov portal. We're going to go over the data profiles product, quick facts, and Census Geocoder. And one reason I wanted to do this workshop is because maybe if you are an experienced census data user, some years ago, like for me, I was using the American Fact Finder to get my census data. Well, as of a few years ago, they got rid of that. And now everything you need to do in terms of getting your data actually is done in the data.census.gov portal. So hopefully this workshop will be helpful for those who are still trying to adjust to that change, because they are still making improvements along the way. So this is just what you'll see when you go to the data.census.gov data portal. And the nice thing about this portal is that you're able to visualize your information in different ways. So you can visualize it in a tabular way, or in maps, or like kind of like a report type of format. And then the next product that the census has is data profiles. So it's essentially a snapshot of a particular area of interest. As you can see here, this is a snapshot of the United States based on various dimensions, but also you can go down to the state level or county level, or in the case of St. Louis, the city level. And then another product that I like is Quick Facts. This is essentially good to know if, like, for example, you're writing a report and you need the population of a state. You can just go to Quick Facts, enter your state, county, city, or town, and get that information quickly, which is why it's called Quick Facts. And you also can visualize this information in many ways. You can create a map, you can create a chart, you can create a dashboard. And if you want to export this information, you can click on the More tab and do that. And then also, one of my favorite census products is the Census Geocoder. I feel like this is a product that maybe does not get a lot of publicity, but it's really great because sometimes I get questions about, oh, I need this, like these set of addresses geocoded. I don't know how to do it. Well, the good news is that the Census Geocoder, all you need to do is you can download a CSV file that has it formatted the way that you need to format it. So you format your data based on that, and then you can just upload it to the Census Geocoder, and then it'll spit out the results in a different CSV file. I will say that it's pretty accurate, but it's not perfect. So some addresses it won't catch, but it's pretty good for a free product. So I highly recommend, if you ever have any issues with geocoding, that please go here first, because it is by far the easiest way, in my opinion, to geocode your data. And sometimes what I would do, and I don't know why, sometimes it works, like if I see that it couldn't match something, sometimes just putting the address in the geocoder and one of the options will give you the result. So, oops. So let me, I'm gonna stop this, pause to share. And I'm going to check to see if there are any questions. Is there a way to download the R code to run it locally in RStudio instead of the cloud? Okay, it seems like this question has been answered, but I definitely will go over it when I get to this point of the workshop. There is a way to download the R code and run it locally. So I just want to first show you the Love the Census document. So we're going to do the tables demo first, and then we'll do the maps demo, and then the data profiles, the quick facts, and the Census Geocoder. So now I am going to start doing the tables demo. So what we're going to do is that we're going to get data by the census tract and display it in a table. So I'm here at data.census.gov, and what I'm going to do is click on advanced search. And this is what the screen looks like. And when I want to do this for find particular data by the census tract in St. Louis. So I'm going to click on geography under this find a filter section here. And then after that, I am going to click on tract, which is the smallest statistical unit. But no, it's not the smallest statistical unit. That's the block group, but it's one of the smallest. And I'm going to click on Missouri. And then I am going to move down to St. Louis City. It is listed under the county section because it's its own special administrative unit. And it's just easier to just put it under that level as opposed to make a different level. And then after this, I am going to click on all census tracts within St. Louis, Missouri. So that is highlighted, which I can see here. The next thing that I'm going to do is go under topics and click on populations and people. What I'm going to do is I want to learn about the various languages that are spoken at home by census tract. So it is under this setting here. Then after this, I'm going to click search. I want to actually narrow down my information by year. So I'm going to click on years and click on 2010, and it automatically filters for that. And then I'm just going to close that and then look at my tables. And the table in which that is under is S1601, language spoken at home. And I am going to click on this. And then it gives me a variety of information by census tract. And it gives it to me by percentage up here. And then it gives me, as you go lower, you see the actual numbers. So there's a lot of information here, and we can do many things with it. So one of the things that we can do with it is, if you want to see how this plays out visually, we can actually make a map and see the spatial distribution of the various languages that are spoken at home. So I'm going to just stop here and see if there are any questions. Yes, Jennifer, tracts are nice. That is an issue with census data. You really should think about, like, when you're using census data, your research topic at hand. If it's a very sensitive research topic, you might not want to go like to the smallest statistical unit, because that can lead to identifying, like you can identify vulnerable populations and maybe put them more at risk. This kind of has happened before in research, that people thought, oh, going down to the smallest unit to help a vulnerable population, that's going to be that most helpful thing. But then that information was actually used against them. So just think about that when choosing the particular geographic level for your data. And then I have a question on any advice when it's appropriate to use the census total population versus ACS estimates. Are you talking about like the bicentennial, the 10-year estimates? It really depends on like what you're doing and the time frame. Like if I'm doing something and I need to know like a 3-year change in something, then I would use the ACS. They send that out every year. But for total population, I mean, like I would probably use the bicentennial just because it was more intensive type of process. I never really personally, I personally just use the ACS. And if it's like a 10-year difference, I'm like, okay, let me just use the 2 bicentennial censuses. Right. That is true. Many attributes are only available in the ACS data set. So yeah, it just really depends on what your question is and how long, like, because the census has the short form and the long form, so it just really depends on your question. And thank you, Bill, for saying that many attributes are only available in the ACS data set. That is true. And my question is, what are my thoughts on how to combine data pre-20 versus post-20 since the block through census tract change? Well, actually, we kind of sort of, well, I think I can't say kind of sort of, I feel like I can definitively say, and my coworkers can shut me down or support me, that we actually have a research guide on how to deal with that within a GIS framework. And it's called apportionment. I can't say, but there is a way in which you can deal with that particular issue in GIS. So, and I'm sure, I don't know how that would be done in, say, R or Python, but I definitely know how to do it in ArcMap. Sure. Bill, could you please share that guide? And we have the person who made the guide here to answer any questions too. I did not mean to put you on the spot, Bill, but I kind of did at the same time.
No worries. I will. I can't talk and browse at the same time, so I'll share the link to that guide here in a moment. Yeah, one of the issues is the apportionment, like Doris was saying. We can assign portions of a value that occur in, say, a 2020 census tract into other overlapping tracts based on area. That's called apportioning. The other issue I think that Rebecca might be talking about is the idea that these boundaries are changing over time, and the Census Bureau will go back and update the boundaries based on targeting a certain amount of population within those tract boundaries. And I do believe that and I don't have direct experience with this, but I do believe the Census Bureau publishes some crosswalk data that would allow you to, cleanly associate older census tracts with newer values. But as I said, I don't have direct experience with that particular issue. I'll get a link to that apportioning LibGuide and put that in the chat.
Thank you, Bill. And thank you for all the wonderful questions so far. Now we're going to move on to the maps demonstration. So the one thing I really do like about this new census data portal, is the ability to easily visualize your information in a map. That was not the case for American Fact Finder. And just to confirm, everybody can see this, okay?
Yes.
Thank you. So, so this is pretty much like what we did before. It transferred over in this map form. So one thing that I mentioned before that I'm interested in is knowing the percentage of people who speak a language other than English. So I can click on this variables icon here. And then I can go down here and see the estimate, speak a language other than English total. So I'm going to just click on here. And as you can see, you're getting to percentages of that. When it comes to mapping data in a map like this, which is called a choropleth map, in which you're having colors represent a particular frequency of a given phenomenon, is very important to use percentages and not whole numbers, because whole numbers can really not give you the complete picture of an area, especially when it comes to rural areas. So it's always important to go with percentages. So as you can see here, you can see that, you know, the areas highlighted more and darker blue has a higher population of people who speak a language other than English. And then this is broken down by census tract. So we can also see other specifics, such as the specific language, like, for example, speaking Spanish or Spanish Creole. And as you can see, the distribution is more south. And if we also do the Asian Pacific Island languages, as you can see, the distribution actually changes and it goes a little bit farther up to the central part. And then you can do other things with this map as well. So if you don't like the color blue, you can feel free to change the color by clicking the colors icon, and you can change it to any color of your choosing. I personally like, if I'm talking about something like a frequency, and I just want to know, like, oh, what's the percentage of someone doing this, I would stick with sequential. If there's something in which I want to know that something, like, there's an average and I want to know how much something deviates away and that's above, then I would probably use diverging scale. And then for qualitative, it's really like, for me, like kind of like nominal data, like, oh, the kind of restaurants that are in St. Louis, the number, you know, or something like that. That's where I would use qualitative for more like nominal data, names type of data, categories per se. And so other things that you can do, and this can just go down a huge rabbit hole, so I'm not going to explain it in its fullest, but you can also change the number of data classes that you see. Right here, you can see that there's 5 data classes. You can change them to, you know, even more or less. It just all depends on what you want to see, how much variation you want to see in your data classes, and then also the classification types as well. If you know, like, your data is normally distributed, you know, maybe natural bit breaks is a good one. If your data is more skewed, maybe use quantile. If you're one of these people who want to have, like, every 5 percentage points, there's a data break, use equal interval. So it just all, so that is the nice thing about this updated portal, is that not only do you, you know, you're not, you know, you can change the colors, but you can change the data classes and the classification types. And I'll say, when you want to consider this whole data classes and application types, at least in my experience, is like if I'm working in more rural areas, I might need to see more delicacy, like like a more delicate like district, like change. So I might need to manipulate those data classes, and I might change the quantile because maybe the data might be skewed a particular way. And again, I'm just speaking from my experience working with census data. So this could vary. And one final thing I want to mention is the base map. So the base map is the underlying map that is like on the data. So like it's under the data. So like all of this gray is base map. And you can either have no base map, which I would not I mean, if you want to, I like a base map. So you can have a more detailed one where it actually shows like the highways and things like that. So that is the maps demo. I am going to stop here and just see if there's any questions. And it seems like we're pretty good. So I am going to move on to the data profiles. So the way we get to the data profiles is we just go to data.census.gov, and then it's actually going to be, one second, if you're going to have to scroll down a little bit here. And right here is the data profiles. I personally like this. Like, for example, maybe you're working for a community organization and they just need a quick write-up of like the area of interest. The data profiles does that for you. So as you can see, the default data profile is the United States, and it gives you information like the total population, median household income, total households, et cetera. And then it breaks things down more into specific information. And you have the view options. You can display the margin of error, or you can share or export. And if you want to actually see an area that you're interested in, you just click on explore your state. I'm going to pick on Missouri. And yeah, you can see, the information that's specific to the state. So this is a pretty straightforward product. So another product that I find useful is Quick Facts. So we go to Quick Facts by just going back to the census.gov page. And then we go to Explore Data main. And then after that, we are going to go down to the Data Tools section, and we're going to click on Quick Facts. But just to show you, see, there's a lot of data tools and a lot of data visualization. So I highly recommend after this workshop is over, is to just take a look and see the various data products that are available by the census, because they do a lot of good work. So I'm going to click on Quick Facts, and it's really straightforward. It starts out with showing you the whole population of the US and just the demographics based on various characteristics. But if you want to narrow that down, all you need to do is just go in here and start typing away. And I do like how they have like your autocomplete options. So I'm going to click on St. Louis City, Missouri. And what I'm going to do after that is you can select a particular fact. So what I'm going to do is I'm just interested in knowing the percentage of people or children under the age of 5. And so now it gives me this information. And in St. Louis City, it's 6.4%. So that's above the national average. And you can also visualize this information in a chart. And to do that, just click on St. Louis City. And you can see the various, you have the city, but then it also compares other places as well. And then another nifty function that actually has the map function in, so I'm not going to bother to show that, is the dashboard. And again, you can click on St. Louis City, and it creates this really cool dashboard that shows the percentage of children under the age of 5 by county. And if you want to export anything or share it, like if you're like, okay, this dashboard is exactly what I need, you can print it, or you can embed it in a website, or you can share it online, or you can email it or print it. So many options to share here. So that concludes like what's the actual census website. The next thing we're going to do is go over to Geocoder, but I see like there's no, if there's any questions, please feel free to ask. Right now, I don't see anything in the chat. Okay, I am going to go on to doing the demo for the Census Geocoder. So, so this is the website of the Census Geocoder, geocoding.geo.census.gov. And this is, you have various options here. So one way we're going to see like how each option is a little different is by using the address of the St. Louis Science Center. So let's first start out with doing the one-line address processing so you can see what it looks like. So with the one-line addressing processing, you just put like the whole location. And for these benchmarks, it's like, do you want to use the current one or the ACS 2021 or the Census 2020? I don't really bother with these, to be personally honest. I just keep with whatever is current, and that's good enough for me. And so when you click the get results, you get just the your match address. So it did match based on this benchmark. And then it gives you the longitude and the latitude, and then the Tiger Line ID. So the Tiger Lines is a census product that's used in geographic information systems. And it's the same with also like the address range. There's Tiger Line products in which you can see the address range of a particular area. It's used to locate your address somewhere without getting too much in the weeds about like how the technical process, but you need this information to do that. So yeah, it just breaks everything up in components. And so now if you looked at the parse address processing for this, is everything is broken up in bits. So you just put the street name here, and then the city, state, and then the zip code, and then you still just, you get the same results. The reason why this, like they have this option is because it is highly recommended, and even the Census Geocoder works this way, to parse your addresses into bits. It's very, like, the geocoder won't work, and you'll see why very soon. It does not work with one line addresses. You have to have a field for house number and street name, a field for city, a field for state, a field for zip code, for it to accurately attempt to find where it's located. So let's say that you have a bunch of addresses of museums. You want to create a map of museums, and you have a CSV file with them. And that CSV file is located in your in that Love the Census folder. So, and you don't want to individually put the addresses in here like this because it's extremely tedious. You can do batch address processing in order to not have to deal with that. So what you would do is download the sample CSV file, which I already did. So the way it will look is, and I'll just show you what the data looks like in the formatted template for the sake of time, is, so this is my museum CSV file, and I might have to, can everyone see this? If not, I will change the share. I'll actually do a share to the full screen. Okay, it is to the full screen. So
you can see the table, Doris.
okay, great, because I wasn't sure if I shared my full screen or just one window. So great. So this is how it has, like, you have to break everything into bits. And actually, and it'll show you too, it'll prompt you and tell you, like, put the address, city, state, and zip. So just make sure that you do it like this, and you have an example that you can use now if you're trying to do this with your own data, if it doesn't make sense. And yeah, once you do that, what you would do is just select your address file and then just put it in the select address file option, and then it'll show the option here. So if I were to go to documents and go to, just to do a quick run through, it might oversave. So I would get my museum CSV file and see it would highlight that. And then after that, I'll click the get results, and the results will show up here. So I'm just going to open this up, and you see it shows you whether it matched it or not, or there was a tie, which it might just show up nothing. And it'll show you if there's a match, was it exact or non-exact, and it'll give you the latitude and longitude and the tiger line IDs and all of that there. So I highly recommend that when it comes to geocoding. I even do this, and I'm an experienced GIS user. I always go to the Census Geocoder first, because for me, it's just easier. So yeah, highly recommend that. So now let's look at the find geographies, and we'll just put in that same address. And again, you can change the benchmark or vintage. I personally never do that. I just don't. I always just like to keep it current. I guess the only thing, the only reason you would is that you received guidance that you needed to, or something like that. So with the geographies now, the difference is it really breaks down, like, okay, this is a legislative district, this is the state code, so the Fips code, and then the geo ID. So this is very much centered, like if you are using GIS data and you're wanting this kind of information on various geographic levels. So that's really the main difference between just the find locations and the find geographies. And I'm not going to go, and then the parse address processing, it's the same thing. It'll show the same results. And then you can also have the information with the batch address processing as well. So, and something that is really important is this text right here. Batch files may not exceed 10,000 records. Now, I don't, like for me, I've never hit that 10,000 record like barrier, but it is very important to know if you're doing some major geocoding, please keep this in mind. So that is it for the Census Geocoder. I'm going to, are there any questions before we move to the programming portion? We'll take a 5-minute break. And I will, okay, I see there's no questions in the chat. How do I overlay demographics on CSV file? In a map, like using a particular, like there's many ways you can do it. In map form, you can do it using the, you mean in the CSV file, not map form.
Hey, Doris, I can pipe on this. Hi, See-Through, this is Bill Winston. How are you? So I think the question you're asking is, how do you get a CSV file which would have demographic information on it, and you want to pull some information, say, from the census tracts and add that to the CSV file? Is that where you're going here? Yeah, okay. So technically speaking, your CSV file should have some type of locational information in it, whether it is an address or a latitude and longitude to be a point value or something like that. So the CSV file would need to have some locational component so that you could then identify what census geometry you were, or the exact census geometry you were lining up with. Let's say you had a table of businesses and they were all located at a certain latitude and longitude. Well, the idea would be you need to take that latitude and longitude, place it on the map, and at that point, identify what is the census tract number for that particular location. And then, of course, you could extract that tract number, add it to the CSV table, and then you would end up with that information in the table, and then any of the census data that was available at the census tract level could be incorporated into your table just by lining things up using the census tract number as a key.
Right. I was about to say what Rebecca said. Personally, I would do that in R using join functions, which I am not going to cover for today because joins can be really tricky for people who do not understand the concept behind it, you know, because there's join, left join, right join, anti-join, et cetera, et cetera. But essentially, just to reiterate what Bill said, you want something in two tables that have similar, like it could be like the tract ID, and that's called the key. And you want two data sheets with the same key, and then you can join them together based on that. And what your join would be is based on what you want it to be, which I can, when we get to the coding portion, just plop in a link that has information about those type of joins. But yes, I highly recommend using something like whatever programming language you're familiar with, R or Python, to do that. And then what you can do after that is export what you joined into a new CSV. And I will show you like how to export a CSV in R and in Python. So at least you'll have that. But at that, are there any other questions? Thank you for the questions so far. Okay, so it doesn't seem like that we have any questions. So what I'm going to do now is to give everyone like a stretch break, because we've been going for almost an hour now. So we will reconvene at 3 o'clock. And in the meanwhile, what I will do is drop that link in to the different type of joins. So you can have that information, C2, and anyone else who wants that kind of information. So I'm going to pause the recording right now. Okay, everyone, it is 3 p.m. So we are going to now do the second half of the workshop. Can everyone see this? Okay. So now we're going to talk about census APIs with Python and R. So an API is an application programming interface. Essentially, it is something, think of it without getting like too like in the weeds about this, think about it as it's something to help you get something. So essentially the API is like this particular like code or like sequence of numbers or whatever that's specific to you. You'll get access to it. And then you can use that in your program, Python and R, to get particular information from the census website. The main advantage of this is that like you're not jumping through many hoops. Like you're not like, okay, I'm going to first download the data, then I'm going to do this, then I'm going to do that. You can literally do everything within the ecosystem of your programming language. And that is what I like about using census APIs. Personally, I like it even more when it's embedded in a library, such as the census data Python library or tidy census package. You can definitely use the API like on its own, and there's a documentation on the census website about it. But I personally think that I'm more of a, KISS principle type of person. So I like to keep it simple, silly. And I just like using these libraries, which are really great when it comes to, getting census data. So we're going to switch over to that now. Just to plop this in, so this is the repo that I have the Jupyter notebook on. Now you can feel free to download this Jupyter notebook, but I am going to actually run not this, which as you can see, it will have like all of the code output running as I mentioned before. I'm going to actually run it in the notebook here, and I am going to, you're going to see the code output. So if you're an experienced Jupyter notebook user, and you were able to set it up, beforehand, feel free to follow along. But these are the things that we're going to do with both coding language libraries. And I wanted to show the same task so you can see how they manifest itself differently in each of the packages. So with this demo, we're going to, I pretty much based it on the census package data package documentation. Again, I'm kind of a KISS like principal person, so no need to reinvent the wheel. But in this demo, we're going to search for education and employment related variables. We're going to search for state and county Fips codes. And if you don't know what that means, you will know by the end of this demo, and you'll understand why I put that link in about finding that information in the chat. We're going to download block group data for St. Louis City, calculate the percent unemployed and percent that didn't obtain a high school diploma. And then we're going to export this data into CSV files. So the first thing I needed to do, and I already did this, so I'm not going to run this particular program, a piece of code here, was I needed to install the census data and the pandas packages to my version of Python. So I already did that. And now what I'm going to do next after a successful installation is import these packages. And I click Shift Enter for that. You can see there's a little star that showed it was processing, and then the one means it's completed. So both of these packages have been downloaded. The pandas package is like a package used a lot for data science applications. It allows your data to be put in data frames, which really allows you to easily analyze your data and manipulate your data in particular ways. So that's why I'm using pandas. And anything you see as like it literally means what it says, import pandas as PD. So anytime you see a PD, it's calling that pandas library to do a particular function. And so I just wanted to set some aesthetics here. So in this code, I'm going to do Shift Enter again, quickly was done. It's just like to manipulate like how the way the data is being displayed. And then I also wanted to limit the number of decimal places that it shows. So we are going to be searching first for unemployment variables, and I'm not going to read out everything, but it's based on just various dimensions such as health insurance and the total unemployment, and then like people who are unemployed that are at or above the poverty level with or without a disability. So the way that we do that is, nice thing is that we can do a search with the census data package. So library. So this shows that I want the ACS 5-year survey, American Community Survey for five-year estimates, the year 2015. And then I want the label, which is unemployment. And then I don't want every single thing in the table at all. So I just want like just particular labels. So these are labels. So essentially what I just did was to show me the labels based on unemployment. If I got rid of this, it would probably be a lot more, but we're only interested in certain ones, which is why I had the 80, this particular setting, which just gives me the 10 that I needed. So I looked at it before and I just narrowed it down based on what I saw. So as you can see, it gives me every like data table that has something about unemployment in there. So what I would do at this point personally is use the knowledge you gained in the previous demos with the census tables, and you can plug these tables in the data portal and see what they show you. That's what I would probably do. That might be the easiest. So after taking a look, I realized what the table I really want is the table that's listed in B2305, which is the employment status for populations 16 years and older. So what I would do is I will fill out this function that will print the table of this census table that I want. So if I just click Shift Enter, it shows me the particular variables in this table. So it shows me that I have the estimate and the labor force and the total number that are in the armed forces and not the armed forces, and so on and so forth. And you'll see how this is important as we go further down in the demo. So the next thing that we are going to look for are education variables that has it. So it's going to be broken down by sex and the total population, and then the total population spoken at home. So we're going to do the same things. I'm going to do now based on, oops. Another thing is like concepts. So just another way of dealing. So that would be probably more like focused on the actual like this. And I only got 50 of those. So well, actually the concepts I think would be more this. I apologize. So I just narrowed down the 50 that I wanted to deal with, because again, it can be a lot. So after I look at all these tables, again, I would probably do this on the census data portal, just take a look at what I'm interested in. I decided that table B15003 is exactly the one that I want. So then I'll just see all of the particular variables that are there for this. So I'm going to just check really quickly to see if there's anything in the chat, and there isn't. Oh, how did you figure out? Because I did it beforehand. If I were to show that process, that would have taken a long time. But I just you have to first look at the tables. If you click on the documentation, if you, the census data documentation has the demos, which I'm more or less doing, but it's essentially looking at the data tables and seeing what you want. Because, some of these census data tables, they just keep on going and going and going, and you don't need all of that information. So really, that would be something that you would have to look at the data table and just figure out. I'm cutting out that step just because it would literally involve me digging through a table and trying to figure things out. So yeah, the documentation is available. It should be right here. If you click on census data documentation, you'll get more of a detailed information about that. Thank you for that question. Is there any other questions before I move on to talking about Fips codes? Okay, I will just go on. So Fips code, knowing your Fips codes is so important. And believe me, if you're working with the same region over and over and over again, you are going to memorize the Fips code quite easily. But Fips stands for Federal Information Processing System Codes. You have your state Fips, which are 2 digits, and then you have your county Fips, which are 5 digits. So like for county Fips codes, the first 2 digits will represent the states, and then the other 3 will represent the county or city. And you can actually look these codes up. Like if you don't want to just Google it and you're just in kind of like a Python streak, you can just actually look it up in Python, and you can do it using this census data.geographies function. And then what you would do is enter in census data.censusgeo, say you want the state, the star is a wild card, and ACS is American Community Survey, 5-year estimates, and then the year. So if I just do that, you get a plethora of census codes here. So that is a nice thing about this, is that you can easily look them up by state. So since I'm interested in Missouri, I want the state Fips code of 29, but we're only halfway there, because if I want information about St. Louis, I need to narrow that down. I need to not only have the state's Fips code, I also need to have the county's Fips code. And so I can also do that by getting the state's Fips code, which I did here in that census.geographies function. And then I'm doing census data.censusgeo, which allows me to look up the particular state and the county and the type of survey in the year. So now I'm just going to look up all the counties in Missouri. And then I am going to just find St. Louis City here, which is 510. So I see that there's there's just a thank you. You're welcome. So now we have the important pieces so we can find these St. Louis City specific variables. And so what I want to do is, as opposed to just like, okay, let me see what's going on here, I actually want to save it to a variable. So the way I do this is I create this variable called STL_BG, which pretty much is St. Louis block groups. And I can actually download that census data that I want. So I wanted to use the American Community Survey, year 2015. And I put in my census data, census geo options, which includes the state Fips code, the county Fips code, and all the block groups, and all of those variables that we saw previously for employment and education, I entered here. This is like, I will say there's just no way around it. You're gonna have to find your variables that you need, and just, if you wanna narrow it down, do it this way. So I'm gonna create this St. Louis block group function. And so then after that, I need to calculate the percent unemployed, and then the percentage of individuals with no high school education by block group. So that's a simple division. So that's just going to be like, I'm going to call this percent unemployed. This is how you create new variables in a particular data frame, which is what this is actually, is a data frame, a pandas data frame. So what I would do is create this percent unemployed, and then I'm going to divide this by the number of unemployed, by the total, the percentage of individuals. Oh yeah, that's right. That's unemployed by the total number in the block group, and then multiplying it by 100. So I'm going to run this code, and it's ready. And so then I'm going to do the same with the percent of no high school, which involves me like actually having to add a bunch of variables because they break things. The nice thing about the census is that they really break things down. So it's not like, let's see if I can go back up and kind of show you like why. Like it literally goes like, this is how, here's the educational attainment, So you have to put in all of these variables here. I guess you would, yeah, like all of these variables here to get that estimate. So you have to do like a little bit of like work in order to get your what you need. So now we're going to calculate that percentage of high school and add everything that we saw and divide it by the total number of people per block group to get that, and multiply it by 100 to get that. So now we have these calculated. These two variables are now added to our STL_BG data frame. So what we need to do is actually like get those only those two variables. That's all we want. So what we're going to do is I'm going to just get those two out, which means, so you have to put it in the double brackets here to do that. And then write the variables of interest. And then I just want to, so you can just see like which ones has the highest percentage of unemployed. I mean, yeah. So, and you could have done it by no high school. I just did it by unemployed. So the nice thing about like using a Jupyter notebook is seeing the output immediately. And I only chose, so ascending equals false. So it's showing me these, and then the head 30, that means only take those top 30 values. So you're seeing the top 30 census tracts that has the highest unemployment. And so once we're done, we can export this into a CSV file. And the way that you would do that is use the census data.export CSV, and then name your CSV file, and then what data table you actually want to export that out to. And I can show you okay, I don't have that result here. So what I will do is just do that, and it is done. So that will be in my downloads folder. Where is it? Should be in there, actually. Hold on one sec. Oh, here it is. Sorry, there it is. Because I'm running my notebook in this particular Love the Census folder. So that's where it ended up being. And if I click on that, you can see it shows me my like variables of interest that I was only interested in. And then the state, which is Missouri, county, St. Louis City, and then the particular tract and the particular block group, and then just the whole name of that. So that's one way in which you can get your CSV with the particular demographic data. So I am done with this particular portion of the demo. Are there any questions? Okay, I'll take that as a no. And I will move on to the RStudio Cloud interface. And before I before I do this, I want to give everyone an overview of our Studio Cloud for those who are unfamiliar with this interface, because it can be overwhelming to those who are new to dealing with this interface. So I'm going to put this in the chat for your convenience here. And so when you get our Studio Cloud, I don't know if I can just do it. I don't know if I can just show like the login since I'm already logged in. I don't think I can, but maybe I can just show this. So if you don't have an RStudio Cloud account, then you would have to sign up for one. You can sign up with one for your GitHub. If you don't have a GitHub, they've added more options. It really used to be a little bit more limited, but now you can actually sign up with Google, which is convenient. Or else you can just do an old-fashioned sign up where you give all your like details. So if you have not done that and you want to follow along, I highly recommend that you do that. I'm going to just keep on going though, since I want to make sure I can cover as much as I can. So you can also, like, once you get this, you can actually save this to your RStudio Cloud account, I believe. So I created this in an R notebook, which is kind of like, you can use a Jupyter notebook in R, but this is RStudio's own product that's supposed to work the same as it. So if you wanted to download it, I think you can just, there is a way that you can download it more. Yeah, you can, I think you can just export it and then click download. If you want to download this .rmd file, so .rmd stands for R Markdown, into on your local machine and run it on your version of RStudio. I just wanted to cover that because someone asked that before. Okay. So so just a few things about the R notebook. It is, you use the R notebook with a combination of the Markdown language, which is what's all here in the white. So I'm not going to go over like all what Markdown is, but the what's in the white is the Markdown language. And then after that, what's in the gray is the actual code chunk. And the way we're going to run this is we're going to press the play button and run the current code chunk. This is my particular Census API key, but it's highly recommended that you get your own API key to do this. So let me just minimize. You can minimize your, should be able to minimize, no. Okay, that's the output, sorry. So you can press play and then you can run your code chunk. If you're like, oh, this is really like not really doing it for my eyes, you can do something called knitting. So that just means you can export it to a particular document. That is the nice thing about Markdown language, is that you can knit it into an HTML document, you can knit it into a PDF, and I believe you can knit it into a Word document here. And sometimes it takes some time to do that. And you will see this rendered notebook here that has, like, for example, I'm just gonna, for comparison. So this tidy census demo here is the same as, that's the same as this. So So yeah, if you kind of want to just literally follow along and not run the code chunks, then you can do this because it actually runs the code chunks for you already, kind of like what it was with what I showed in GitHub. So everything's already rendered. So it just depends on how involved you want to be here. If you want it to open up in your own browser, you can do that as well. And I just click the open in browser button for this. So let me go back to my RStudio Cloud. So this is the environments area, which will show all of the variables that we created. And then this will show like the actual, like the console will show like what's going on in terms of the output and what, you'll get the error message here, which you really, like all the good stuff and all the bad stuff too. Before I start, I'm going to check to see a question. How do you get your own Census API ID? I literally just Google Census API and that, because I don't know the particular name of the site, and that's how I do it. It's just Google it, and then it's just very blank, monotonous form. And then you just put your name and email. And then after that, you'll get like a response, within the next few minutes saying, this is your ID. And it's really simple, Rebecca. Thank you, Brian and Molly. It's super simple. So I'm gonna move on now to talk about the Tidy Census demo. This was created with the same idea in mind with what we just saw with the census data library. But there's two catches. So the R framework, in the R universe, I guess, they want to promote what's called the tidyverse, which is a particular way of formatting your data, which makes it easier to do the analysis on. And I'm not going to go into all of that. So the tidy census is based on that kind of foundational framework of creating a tidy table. So we're going to do that. And then we're going to do something that I find very interesting that makes Tidy Census unique, is actually be able to create maps with the program itself. So I'm not going to run this because I already ran it and it's going to just take forever. So if it does take forever, just let it run, and you can always get back to actually clicking on the code chunks. So we're going to look for the same variables as before, unemployment and education variables. So this is pretty much explaining this. So what we're going to do is first load all of our variables. In this new variable, we're going to create called V15. And if I click on this, it shows me, and this is one thing I like about using RStudio, is that it shows my data frames in a very nice format. You can see like that you have the labels here and the concepts here, and name of the particular ones. So actually, so you can do quite an easy search for what you need. So one way we can search for that same like B2305 is we can go under label here. Oops. Filter. And then after you click filter, you can just put in under the name here, and you have all of the particular variables of interest right here. So that is one thing I like better about using RStudio. And then we can also do the same for education, because all of the variables are in this V15 variable. And I highly recommend when you use Tidy Census, create a variable containing all your variables so you can look them up later. And as you can see, I have 25 entries here for what I want in terms of education. And then, we can also do like I said, if you don't know what you want, you can also just, type to what you want as well. So there's just many easy ways to look up your data within this data frame. So I do think that's one advantage of Tidy Census to census data. So now what we're going to do is get those education and employment variables. And we're going to use the get ACS function to do that. So we're going to get it for the unemployment for that table B23025. And then we're going to also get it for the education. So going back to what I said about the tidy way of doing things, I'll show you what the output looks like when it's wide and what it looks like when it's tidy. So first, let me just, I'll just change these variables here. And it might take a little bit. Oh, I actually kind of did it already. Oops. I'll change that again. Let me stop this. Let me redo this. I'm sorry. I just realized I actually have like variables showing what the tables look both wide and both in the tidy format. So it might take a little bit to get this data because it is quite a bit of data, but it quickly finished. So let's just look at the, let me close this to keep my tabs under control. Let's look at the tidy version of the St. Louis block group. So the very important thing to notice here is that the tidy way of doing things is that each variable is within the, each like column header, because in census data, these were all columns. They are actually variables in the tidy format. If you look at the STL BG wide, you can see that these variables are actually columns. That's why it's called wide, because all of these columns are being 53 total columns here, as opposed to the tidy format, which is 6 total columns. So that's one goal of the tidy way of doing things, is to reduce the amount of columns that is in a particular data table. So just to show what the difference is. And so then also another thing is these numbers here is in variables called estimate and MOE, which stands for margin of error, as opposed to being an entry in here. So there are times in which this is very useful, but for our purposes of calculating things, we are going to do it in the, we're going to do our calculations in the wide format, given the way we're going to calculate things. But it is quite useful. There's pros and cons to both. And I do like how in the, and there's particular functions you actually use in R to turn your data into wide and tidy. And I like how you don't even have to bother with that, because that can even be confusing for people. How do you see the variable names so you know what each one means? Well, so essentially the way like I mentioned before, it's highly recommended that you create a variable name table. Now, what you can do, kind of going back to the previous discussion, trying to like go about joining demographic data together, what you would do is get this table and then join this table to this one by a variable. So that is one way you can do that particular thing. If you're like, I don't want to keep on going, you know, back and forth, back and forth. So I would just do a left join or something like that, so you can easily see what the variable name is. So, did I answer your question? All right, thank you. So you can see like all the output is here. That's also a nice thing about the R notebook. It shows step by step, but if you're like, this is way too much for me, you can always exit out. So now we're gonna do the same calculations that we did before, calculating the unemployment and the percentage without a high school diploma. And so these are just like an overview of all the variables. So we used pandas and Python and like did manipulation. Well, the function in R to do more or less the same thing is called dplyr. And dplyr is a package that what they like to say, you use particular verbs to do operations. So if you know what these verbs are, you essentially can do a lot of powerful things with your data. So one of the verbs that you can use in dplyr, so verbs also known as functions, but they like to call them verbs, is mutate verb. So the mutate verb allows you to create a new variable. Another thing about this whole tidy way of doing things that you're probably like, what in the world are these pipe, like this thing here? Well, this is called a pipe operator. And the whole tidy way of doing things, they really want to, I guess they want to reduce the amount of code that's being like used, because usually you would have to create more code to do this. So essentially what I'm doing here is I'm saying, okay, to my STL underscore, like my unemployment variable, and I call it again here, I'm gonna say, hey, I want you to pass this function to create this new variable to this variable. So essentially I'm not like having to create extra code for that. So essentially it's passing the function over to the variable. If you've done some stuff in the command line, they also have this kind of piping type of function. So I created this variable called %unemployed, and then I'm going to do the same thing for education, you know, add up all those variables. So essentially I'm saying here, okay, and this education variable, which I have to call here. If you don't call the variable, it's not going to work. You're going to get an error message. Please add all of this stuff up to create this new variable called %no high school within my wider data frame. That's essentially what this code chunk is saying. And I will just run this, and you will see that I'm going to click on the STL unemployment wide. If you go all the way to the end, this %unemployed is here. And if I go to the education variable, go all the way to the end, and oops. I don't know what happened here. Hold on. Sometimes it, did I not run the code yet? Let me try it again, because I don't know what happened here. Okay, STL. That is really weird. I'm sure if I just do a search, it should do it. Because like that's one thing about the wide tables is that it can be hard to find stuff. And yeah, I just realized it's, so what I did here, just to show you, there's these little boxes here. They should be like little arrows, but for some odd reason, they're showing up as boxes. But you can see it was just showing me columns 1 to 50. And I was like, So I just click here and I'm able to see the remaining of the columns. So you can kind of see why this approach of tidiness, the tidy approach was created, is to kind of like, reduce this kind of thing. And so now the fun part, it's all fun, but this makes it even more fun, is actually being able to map your variables. And there's many ways that you can do this. This is just one particular way that we can do that. And one thing I forgot to mention up here is when I retrieved these variables, the only way I can map the variables is to make sure that in this function, the get ACS function, that I make sure that the geometry equals true. By doing so, I'm just clicking on the unemployment variable. You're going to see this geometry here. If there is no geometry, there is no mapping. So it's very important to have that activated for that. And again, you don't have to, if you're familiar with using the Ggplot 2 package, you can do it there, but also know that you can also actually use other ways of mapping in R to do that. But we're not going to go over that today. So what we're going to do now is to create this unemployment map. X out of that. And so I'm going to explain what this code essentially does quickly, since I have 15 minutes left. So essentially it's the same kind of tidy, the same type of piping format. I'm doing something on this variable. So I'm calling the Ggplot 2 package. I am saying, please fill my map, the census tracts on the map, based on the percent unemployed. This is very specific to the geography. If you want to map something, you need to have a coordinate system, coordinate reference system, CRS. So one of the biggest questions is, how do I find this? Well, again, this is something I just Google. There's also a website called epsg.io, I believe, in which you can look up this information. And so then I say, color my map this way, and I want a title and just some little aesthetics. So I'm going to show you what the map looks like here. I don't know why it does this particular thing, so here's my title, the percent unemployed in St. Louis by block group. And then you can see the percent unemployed, and look and see how it is here on the on the map. And then you have your latitudes and longitudes listed here. And so now we're going to do the same thing for the high school diploma. It's pretty much the same type of code jargon going on. Just please map this variable, use this reference system, and give it a title and kind of center the title. That's what this does. So you're seeing the same thing. So once we're done with that, we can export this data as a CSV function. As a CSV file. I'm going to delete this. Yep. Okay. So, I accidentally deleted. Oh my goodness, I accidentally deleted the actual project. Oops. But essentially, what should happen is that you have like the CSV files here on the bottom. I'm really sorry about that. But yeah. So that is it for the good news is that it is rendered here. So I'm just gonna save this and just put it back in. But yeah, so that concludes the tidy census section. And so I'm gonna finish up here with the rest of other products, and then we can go to Q&A. So if you could please keep your Q&A about R to the end, that would be great. So we did these things. So just some highlights. So with census data, you can download the information by tables or variables or interests. And then you can download the data of multiple geographies. So I can do census tract or, block group, county, all at once. And then I can export that as a CSV file. Tidy census, I think the biggest advantage is just being able to map your data and just be able to choose whether you want to download your data in a wide or tidy format. So now we're going to quickly go over some external products, such as Social Explorer, Policy Map, and iPumis. So we have actually an institutional license with Social Explorer. So the way you would get there is to go to the A to Z databases and to access it from there. And it's just essentially a data product, an interactive data product that's very similar to the census data portal, but just more detailed on like manipulating census data. And so you would have to, this is just the steps. You go to the A to Z databases, you'll see your professional license, and then you log in and you're in because it'll say professional plan provided by Washington University. And then another product, which is similar to Social Explorer, is called Policy Map. And if you were like, what's the difference between the two? I do have a link to a very nice workshop that will show you, that will talk about that. But again, you would access that on our A to Z databases site. And again, we have an institutional license. You can access it for free, but there's more functionalities with the institutional license. And so both of these platforms you can create and share maps, create reports, and download data tables. I highly recommend, if you're not a GIS, like you don't know like how to use some of the proprietary or open source GIS software such as ArcMap or QGIS, or if you're not like a very confident in Python and R and you really need a map fast, that you use Social Explorer and Policy Map to do that. And also my colleague Molly Webb actually believe last year she did a workshop for last year's Love Data Week on Social Explorer, and that workshop is on our data services YouTube channel. So just like what makes Social Explorer different from Policy Map? Well, with Social Explorer, you can create presentations and you can download spatial data, which, that is useful for a GIS user. So it's actually, I think it covers a range of people who use spatial data. So, because sometimes getting that spatial data you want can be tedious. And I've had students just say, oh, we just downloaded it from Social Explorer and we liked using that. And then some functions exclusive to Policy Map, you can actually load your data, like that museums.csv file. You can load that once it's geocoded, you can load it to Policy Map, and then you can see the map of the museums. And then also if there's some kind of data that, like, I don't know, like you're dealing with a project and you need to add sites, you can actually add point locations on the map and then export it as a CSV. And now I'm going to talk about IPUMIS or IPUMS. So this is it's like a huge like database of census microdata. And it has historical census data as well. Also, like the IPUMIS is one big project, but there's a lot of sub projects like NHGIS. So for me, if I'm using GIS, the nice thing about this is you can download the census data and the actual shape file. So the spatial file that you put in your R or Python or, mapping software system to use. And then they also have like time use survey, CPS. We've had people ask for information about that. You will have to apply for it. It is free, but they just need to know who is using their products. So you will apply for it and then you'll get approval for it, not that long after you apply for it. So I highly recommend if you're looking for especially historical data or just more specific data, like some kind of like the CPS really comes to mind just because that was the most recent issue I had to deal with. I would highly recommend going through IPUMIS to get that information. So just to mention just some additional resources. So uscensus.gov has a lot of video tutorials. And then also I have a link to Molly's Social Explorer workshop. And then just the documentation for tidy census and census data. And IPUMIS, for some people, it can be difficult to use. So just to give a heads up, but there's various tutorials on that as well. So at that, I am done. And if there are any questions, feel free to ask me now.
I had a question about using custom axis labels in R with Ggplot. If we wanted to zoom in on sort of a set map and create sort of like a custom coordinate range that isn't pre-specified, isn't like a defined geometry, how do you do that?
So you want to, I'm sorry, could you repeat the question?
Yeah, sure. So like if in the map you created, it goes from like 90.3 wide to 90.2. Let's say you just wanted like to zoom in on the area of the map from like 36 or 38.65 north to 38.6 north and like 90.25 to 90.24. Like if you wanted to change the width of those axes on the Ggplot.
I'm sure there's a way you can do it. I am just not entirely sure. I'm sure it has something to do with the changing of the scale or something like that in terms of the function. But I am not entirely sure on how to do that, because for me, I use another way of mapping for that. But for tidy census, it has a very good functionality with Ggplot 2. But that would be more, from what I understand of Ggplot 2, changing like the scale. So yeah. Let me see if I can.
It's okay if you don't know how to do it.
This is definitely like more, that's more of a Ggplot 2 question
Yeah, I didn't know
Then-
how it worked with maps, and also like how you find and select those coordinate SFs, because what I had done in the past is like preload a shape file
Yeah,
that was downloaded and then map it onto that shape file, but I was having trouble. It was like not zoomed in appropriately.
yeah,
Okay.
yeah, that would be just changing something in Ggplot to more specifically than anything, I believe. Yeah. Are there any other questions? Okay, I take that as a no. So I just wanted to thank everybody for coming to today's workshop. Again, once this video is processed, we have to do some editing and add captions. This video will be uploaded to our data services YouTube channel, which not only has presentations from which will not only have presentations from this week's Love Data Week, but also from last year's Love Data Week as well. So thank you everybody for coming. And I hope that you're able to attend all of the other Love Data Week workshops. And thanks for all the great questions.